In this 2-minute Java lesson, we'll talk about throwing exceptions and why you might want to incorporate throwing an exception into your program during the design. Throwing your own exceptions makes sense as a design choice in many cases. Because methods are used in many places within a program, they may be used more than once in different contexts. Since they could be used in different contexts, the response to what happens with an exception might be different in different places in your program. The program could stop, warn a user, or take a totally different action depending on where it was within the program. So it makes sense to throw the exception and allow the calling program to handle it. Most people think of an exception as a runtime error which could crash your program, and it certainly could be that. But it could also be other dangerous conditions, and you can decide what a dangerous condition is for your own program. In fact, you can design your own exception if you like. It's easiest to see this type of exception in use. For instance, we're going to have an example of a blood pressure monitoring program which uses a method called retrieve blood pressure to read a patient's BP. The blood pressure with a top number over 150 is a dangerous condition. A bottom number over 90 is considered dangerous. This is, of course, an oversimplification, but our method will throw an exception when it encounters what it thinks is a dangerous blood pressure. Here is our method. Now, of course, since I don't really have the equipment to monitor blood pressure, I'm approximating the top number, systolic, and the bottom number, diastolic, with a random number generator statement. So that's what the first two statements do. The second one returns the combined systolic over diastolic number, which is the one that you're familiar with as the blood pressure. Now, if that blood pressure is in a dangerous condition, an exception is thrown. Otherwise, it returns the blood pressure number. Throwing an exception is sort of like throwing a tantrum. What it means is it creates an exception, and then it halts the execution of the method. It returns the execution to the catch block of the calling program. In our example, the calling program in the catch block simply prints out a warning message. Here you can see that program. That program simulates reading the blood pressure 20 different times. It does that by putting that within a for loop. Inside the for loop is a try block and a catch block. The try block attempts our particular method, retrieve blood pressure, to get a reading of blood pressure. If it encounters no problem, it prints out the blood pressure reading with the phrase your current blood pressure reading is, and then blood pressure. If it captures the exception, then what happens is it prints out a warning message. This output shows both the warning and also the current blood pressure reading. This shows what happens when you incorporate within the design of your program some exception handling. Of course, you can do a lot more with exceptions, and designing custom exceptions is one example of that. In the next lesson, we'll design custom exceptions. But keep in mind that exception handling is used as a very useful tool to make programs more efficient. So don't think that exception handling is only to prevent your program from crashing. It may be to make your program respond more intuitively.